Hi, everyone. Thank you for watching this video. In this video, I'm going to present my final year project Debiasing visual question and answering with answer preference. With the research in deep learning, our technology is more advanced than ever, and we are closer to real artificial intelligence than ever. Nowadays, in the field of computer vision, a machine could easily name the objects, find people, inferring relations and actions, and so on. And, in the field of natural language processing, tasks like grammar checking, machine translation, could be done flawlessly, and NLP algorithms could even understand court cases and generate genuine legal documents for you. With all the incredible accomplishment being made, we are still in the very early stage of artificial intelligence. Our machines are struggling to understand what it sees. Visual question and answering is such a task which requires models to generate reasonable answers when it is presented with a specific image and a text-based question regarding the image. And you could see that this task really requires the machine to understand the context and reason about it. And some research address VQA is the Turing test for visual intelligence. This is a typical neural network architecture for solving this problem. The input image and question would go through an encoder and combined as an embedding which encapsulate the context of the image and the question. Then, the embeddings are fed into a generative model to generate the final result. The VQA v1 and v2 are two widely adapted benchmarking dataset for visual question answering. These datasets have provided more than 600,000 questions and about 6 million answers. But, as we could see from this answer distribution diagram, structure in our world and bias in our language tend to be a simpler signal for learning rather than visual features, resulting in models that ignore visual information. So that, the logical reasoning capability of deep learning models is not well challenged, as these relationships are relatively simple and highly correlated with the input question itself. To overcome these difficulties, VQACP dataset is introduced as a new benchmark. VQACP dataset is based on the identical set of samples in VQAV1 and VQAV2 but with a different split. More precisely, researchers have reorganized samples to form a different statistical distribution in training and test dataset. Under VQACP dataset, the performance of normal VQA models would decrease significantly. In this research, we explored the possible origins of bias in VQA datasets. We have found two kinds of bias that may influence the performance of VQA models. In the process of creating the VQA dataset, questions and answers are represented in human languages. Naturally, the feasible answer candidates would heavily rely on the type of questions, and this is called linguistic bias. For example, numbers are the only possible answers for question starts with how many. In addition, there is another kind of bias which is called statistical bias. Within what color question type, majority of the answers are white, but such majority answer in test appears to be black instead. To overcome these biases, we need firstly represent them with mathematical models. A simple representation that could combine linguistic preference and statistical bias is question type-wise answer preference. Practically, we have defined 64 question types, as shown in the table, and counted number of occurrences for each answer. Then, we have designed this training pipeline to reduce the effect of biases. There is an edit branch during training, which will add the answer preference to the final prediction. So, during backpropagation, the model is less biased towards commonly occurred answers. We have tested multiple approaches to normalize answer preference, and the quantitative results are shown in this table. We could see that the Debiased training pipeline has produced very competitive result. With our new training pipeline, the testing accuracy of VQACP test set has improved by 16%. In this figure, the blue bars represent distribution of ground truth answers, and the orange bars represent model predictions. We could see that the Debiased training pipeline has achieved general improvement across all answers, instead of limited to extreme cases.